Hello, good morning, good evening, happy middle of the night, if that's when you like to watch these things. I want to welcome you to the most important of the featured sessions at Atmosphere Digital, and that's going to be the session on security, which is obviously everybody's favorite topic. So thanks for joining me here. By now you've heard Kirti talk about the Edge Services platform, and that's going to guide our future product development for the next several years. So I was really happy to see that the idea of zero trust security made it into one of the core pillars of that Edge Services platform. So that makes me happy. That's exciting for me because it reflects a commitment on the part of Aruba's senior management that security is a core component of the solution. It's not as though we offer connectivity solutions and then a couple of security features. Security is really central to what it is we do and will continue to be that way. So I'm going to go through that a little bit today and just talk about, what is this idea of zero trust security? What does it mean? Before we do that, I think we got to address the huge elephant standing there in the room, and that is this phrase zero trust. And to explore that a little bit, I'm gonna borrow a quote from our friends at Gartner, this was from a presentation they gave last year at the Gartner Security Conference out here in the DC area. And they said, zero trust is being abused as a marketing term. Vendors are applying this term zero trust to market everything in security, creating significant market confusion. I don't want to confuse my customers. And so we're going to spend some time here talking about what does zero trust mean to us? Maybe even more importantly, what does zero trust not mean to us? Zero trust is a destination. It's a framework. It's a concept. It's not a product. It's not even necessarily a set of products. It's not something that we as Aruba can provide to you entirely. It's not something you can necessarily build yourself, with a few exceptions out there. So we need to unpack this a little bit. So I guess the question is that you might be asking, if this is a term that's being overused, if this is a term that is being used as a marketing term, why would we choose it as well? The answer is really because there's a question we get commonly from our customers. And that question is, does zero trust mean the end of network access control? Does it replace network access control? And I know our customers are often the network engineer, and they're hearing from their security teams who are saying, hey, we've decided to embrace this new concept of zero trust. That stuff you do to secure the network, we don't need that anymore. Don't worry about it. It's not that important. And I think that's pretty far from the truth. The reason why I think we need to be talking about this concept of zero trust is we don't just deal with it at the application layer. We don't just deal with it at the network layer. We need to have a holistic approach to what this concept means, and understand the roles that the network plays and the roles that the application plays. So we'll talk about that today a little bit. I first want to give you really a definition of what is zero trust. And Gartner said zero trust doesn't make sense as by itself. It's a modifier. It doesn't make sense unless you add a noun at the end. I'm going to talk here about zero trust framework. The original concept came from Forrester back in 2008, and they talked about zero trust network. All very similar and related, but different vendors and different end users even have different takes on what it means. This is my definition. This is trying to be very general and high level. Essentially, the services that you can access on a network should not depend on which network you connect from. So the fact that I have a presence on a particular network or a VLAN or a segment or a port shouldn't by itself give me any particular access to resources on that network or services on that network. And the second piece is all access to services must be authenticated. That's critical. Authorized, also critical. And hopefully encrypted. We'd like to have encryption. So if this sounds good to you, if this sounds like a good thing that we should do, the very first thing that you need to do is abandon this idea of fortress mentality. And this is not this is not a new concept. This is something that's been around for a long time. We've been talking about the end of the perimeter. Deperimeterization is a word that's been thrown around. The fortress mentality says all of our goodness is inside the walls of the fortress here. Everything bad is on the outside, and these walls, our security perimeter, protects the inside from what's happening on the outside. And we all know that an employee responding to a phishing email and clicking a link can potentially upend that type of a security model. So we have to get out of this mentality, and it's tough. I'll admit to doing this myself, where, hey, I need to deploy a server on the network for a month to do some project to get something done. I'm not going to worry about security all that much because I know I'm inside the corporate firewall, and so who really cares? The firewall will protect us for a while, long enough. And then 3 years later, you look back at that and say, wow, that thing that I meant to protect a long time ago, I should really get back to that at some point. That type of thinking is the anti-zero trust thinking. It's if I can get a foothold into that network, I can have access to that resource or that service. And that's what we have to avoid if we're going to embrace this idea of zero trust. So ending fortress mentality is key to this. I've got a few different definitions from different vendors, from different sources of zero trust and ideas about zero trust. I'll go into a little bit here. One comes from Duo Security, and I like theirs because it was very short and to the point, and they basically said, zero trust networking is replacing trust in the network with trust in the device plus the user. A couple of points there. One is that device plus user needs to be trustworthy. And what if it's not? And that's a question that we have to answer here. The second thing is, what they highlight here is the fact that we're really shifting trust. We're not, zero trust is kind of a misnomer because it's not as though we're applying zero trust to everything. We have to trust something or we get nothing done. And so what they're saying is, we're no longer going to trust the network, but instead we're going to trust that device plus user combination. So we'll talk more about that in the rest of this talk. There was a book put out, published by O'Reilly. This is a really good book. It's long, but it's very much focused on kind of that original concept of zero trust that Forrester coined, which is very application focused. It's saying, network flows must be authenticated before being processed. Authentication and encryption must be performed by the application endpoints and by the client. So the concept in this book is really TLS, HTTPS-based, browser-based applications where I can apply authentication mutually, so client-side certificates, server-side certificates, to give me my trust relationship. So that's great if you're in that sort of a world where everything is based in the browser and the web server. But there are other types of companies out there. I work for one of them. It's been around for a long, long time, and there's lots of legacy stuff out there that doesn't necessarily fit into this kind of a world. So we've got to find a way to deal with those as well. The National Institute of Standards and Technology, or NIST, actually published a draft document on zero trust architecture. I think this was published last year, and they're coming back to do a revision 2 of it. This is a really good document. I don't often say that for government published documents, but this is pretty good and it's worth a read. It's free for download on the internet. But some of the quotes out of there: no implicit trust granted to systems based on their physical or network location. And then the second point says, we focus on protecting resources, not network segments. Now, keep in mind the definition of what resources might mean. We might think of that as server endpoints, controlling corporate data, for example, but client devices, and think about things like IoT devices, those are resources as well. So we need to be thinking about those as well. And that doesn't tend to fit into the classic definition of zero trust. This is a vendor example, and I'm going to claim that this is somebody who is abusing the term zero trust. And the reason I say that, what they're advocating here is, we're going to chop up our network into different zones. We have this campus zone, we have this management zone, we have these different application zones, and we're going to stick this box in the middle, and we're going to call this a zero trust segmentation platform. I'm getting old these days, but back in my day, this was a firewall. And I'm not saying it's a bad thing, but it's not really what the concept of zero trust is all about. The reason for that is, the gap here is that the enforcement is too far from the resources. So think about that campus zone. there could be thousands and thousands of devices sitting in that campus zone. And if one user clicks a phishing link and is infected with malware, and that malware is wormable, that one client can actually infect all the other clients that are in that zone. So going back to Duo's definition of zero trust, if I'm trusting that combination of device plus user and all the devices are infected, that's a bad situation there, because you've essentially got authorized users, authorized devices, but you've got malware running on it. And so how safe is your enterprise data? This is kind of getting into, though, where I think Aruba has a role to play, because we can push that enforcement point back out much closer to the actual resources if we're talking about network endpoints. I mentioned before, zero trust is not something you can necessarily build yourself, with a couple of exceptions. And Google BeyondCorp is one of those exceptions. If you have the resources of Google, and I'm sure some of the Google folks are on the call here, you can and they have. And BeyondCorp has been widely publicized and widely shown as an example of what a zero trust framework really looks like. The essential idea here is Google doesn't care. If you're an employee of Google and you're on a Google resource, they don't care if you're inside the four walls of the building or if you are on the outside somewhere else, at home, at Starbucks, at an airport, or what have you. You access your corporate resources in identically the same way, regardless of where you are. Everything goes through this access proxy, and that access proxy is making a per resource decision on the basis of this access control engine that's sitting behind it, which has a whole bunch of different data points. So one of those data points is going to be the inventory. You need to be on a Google issued device that's managed by corporate resources. It's managed by IT. It has, up-to-date operating system patches. It has antivirus running. It's been checked. All these sort of endpoint posture systems that we've had for a while, those come into play there to make sure that this request is something that we ought to listen to and that we ought to go ahead and process. You notice up on the top there, in a Google building, they're still using 802.1x. They're still going back to Radius to authenticate those requests. So if you're on a Google Wi-Fi network, that is actually a factor that gets factored into the access control engine. So it might say, all of the things being equal, I might apply more trust to somebody who is inside a Google building versus somebody who's sitting in a foreign country where they don't normally sit. But we certainly haven't opened up the network to be a public Wi-Fi hotspot. And I've heard that before with people saying zero trust. That means I can turn off 802.1x, I can forget about Radius, and I can treat my network as though it's a public Wi-Fi hotspot. And I mentioned that to somebody at Google, and they kind of laughed and said, that's ridiculous. We would not do something like that. So this is an example of somebody who's kind of put application-based zero trust out there, but remember who they are and remember what kind of resources they have access to. This is not something that I think just anybody can do. Even working for a company like Aruba or HPE, I don't think we have the resources to build something like this, and not many people do. So given that, if we choose to embrace this sort of a world, what kind of remaining gaps do we have? I'm going to highlight a couple of these, IoT and BYOD being two of them. Those resources don't participate in a zero trust framework. So what I just described for something like BeyondCorp is great for corporate-owned devices and corporate-managed devices, but I've got armies of IoT devices coming into organizations, television screens and temperature sensors and building control systems and this sort of thing. They don't participate in that. You're lucky if they can authenticate at all, but really they're designed to be plugged into a network and they start doing whatever it is that they do. So, and likewise, BYOD, this is an employee or a visitor-owned device. It's not going to participate in that particular framework. The other piece here is protocol support. So what I described with Google BeyondCorp works really well with browser-based applications where I'm talking to a web server. If I have legacy applications that don't fit into that type of a model, what do I do about those? Google actually wrote up for some of the BeyondCorp material how, because some people needed access to SSH, they actually built an SSH proxy that runs locally on the employee device, proxies SSH into HTTPS so that it can get into this zero trust framework, and then they take it back out and let SSH operate. If we have to do that for every single protocol that we have, that can be tough. And I know there's a lot of legacy protocols that are out there. So there are some additional gaps that we still have to deal with. Zero trust networking is not an answer to every single security problem, although it's certainly a good idea from an application standpoint. So let me give you kind of my pragmatic approach, maybe, and you might even think of this as zero trust for networks. And we'll delve deeper into that, but maybe there's a split here of zero trust for networks and zero trust for applications that can make sense. And combining those two together gives us a much better solution overall. So zero trust for networks, the services you access should not depend on which network you connect from, except where you have no other choice, in which case you have to allow it in order to get things done, but you got to control it. So that's one. Second, all access to services needs to be authenticated, authorized, encrypted, except where you can't, because maybe the device or the application or the user can't support one of those things. And then finally, access is subject to change. Back in the really old days, we used to refer to NAC as network admission control, and over time that changed because admission implies I'm letting you on to something, I'm making an access control decision once, and then I'm not going to revisit that. And reality is we might get additional information from other security systems that say we need to come back and change your access rights. And so in this type of an approach, that's exactly what we can do. What do we need to make this sort of thing successful? Well, our friend AAA, and that's something we've heard about for a long time. Of course, Aruba's instantiation of this is called Clearpass. I'm going to change one of these, though, because I don't think accounting is all that important. Instead, I'm going to say access control. So authentication, authorization, access control. Those are the 3 A's in AAA that we need to make a solution like this work properly. So kind of going step by step. Step 1 is really to understand what is on your network, understand traffic flows. If you don't have this capability, it's tough to get a handle on network security. So from an Aruba product perspective, Clearpass Device Insight is really good for this sort of a use case. You don't need that. You can do this with, for free with Wireshark. You can do it with tools like Security Onion and Zeek and some of these sorts of things. You could even do it with firewalls by just putting in permit rules, but having a log option on it so you can see what's out there. The nice part about Clearpass Device Insight is it's going to really try to figure out what's on the network. So what devices are out there, and then you can dive into what are they actually doing. For every device identification here, we have traffic flows that go along with that, and we can say, this device type communicates on these ports at these frequencies, at these times of day, with these byte volumes, and so on and so forth. And those are features that all feed into the machine learning that Clearpass Device Insight does. So this, for me, is really step 1 of understanding what's out there. Step 2 is going to be authentication. And I put a star after the word authentication because I want to put some caveats on that, at least verbally here. Authentication in networking, we tend to think of 802.1x. We tend to think of something that's a very solid and secure form of authentication. And that's not at all what I mean here. What I mean here is I want to have no invisible network connections. I don't want it possible for you to have a device connected to the network and it's just happily transmitting packets forward and back, and nothing else on the network except maybe a network management system even knows that it's there. What I want to have is for every device that's on your network, I want the AAA system, Clearpass in our case, to have a record attached to that to say there is a thing out there with this MAC address and this IP address, and this is perhaps the device type that it is. That's a starting point, because as soon as that record is there in the AAA system, you now have some means of control over it. You can go back in and you can change access rights, you can deny access rights, you can modify, you can change forwarding paths, you can change bandwidth. There's a lot you can do once you have these records actually created. So the idea is use the best authentication possible. If you have PKI deployed, if you have certificates and you can do things like mutually authenticated TLS, excellent, go for it, do that. If you can do 802.1x, that's great. You can have very a very high degree of confidence that the device out there is who it claims it is if you've got a strong form of authentication. What if you don't? What if you have the security camera that's in the picture here? All you might get out of that is a MAC address. And if that's all you get, fine, take it and apply, treat it appropriately. So we're going to let that security camera do security camera things, but we're not going to let it do other things. At least we've got something attached with it as an identifier. Maybe I have really old switch networks that don't really support .1x authentication. They don't talk to radius and so on. Almost every switch that would still be in production today, though, can send Snmp traps. So I plug something into the switch, and it can send a Snmp port up trap and say, hey, there's a new device plugged into me. It's got this MAC address, and it's on port 22. Clearpass can actually accept those Snmp traps and can then add the entry to its database and go out and try to interrogate the device to figure out what's out there. So use whatever you have. Use all of the network infrastructure. Don't just use Aruba's infrastructure. This technique that I'm talking about works with third-party infrastructure as well. And the key to that whole thing is, again, Clearpass to make that work. Multi-factor, step-up authentication. These are all ways to increase the confidence of the authentication, and those tend to apply to more secure forms of authentication. So this, to me, is really the key step into making a zero trust framework for a network functional, is this authentication step. We haven't talked really about enforcement yet. We haven't said any. That's not surprisingly going to be step 3 here. This may take you a while. This may take you months. This may take you a year before you get to this point where you have a view of everything connected to your network and you know what's out there, and you can get that reliably. That may take a while. Then we move to step 3, which is really enforcing that trust, enforcing those roles, enforcing, this is a security camera, and so here's what security cameras need to do. Let's go ahead and enforce those access rights. Versus this is an employee on a corporate issued laptop. I might not want to enforce things at the network there, and that's really where the classic application view of zero trust can take over to say, all my laptops are fine. They're going to be accessing everything through the browser. They're going to be going through their own types of security protocols. I'm not going to worry about protecting application layer data from the network. However, I am going to protect network endpoints from other network endpoints. So a corporate laptop, does it really have a legitimate need to be talking peer-to-peer to another corporate laptop on the same network? In most cases these days, the answer to that is no. And so we can use enforcement in the network to say, your zone, if I go back to that one slide that talked about the segmentation platform, your zone is actually just you, just one device. We're going to allow you to have flows coming into the network, but you're not going to talk to other devices unless that's something that you have to do. Security cameras talking to a DVR, for example. So this is something we can do with access switches. We can do it with access points. We can do it with third-party infrastructure. We might do it through VLAN segmentation. We might do it through firewall rules. There's a lot of different techniques that I can use in order to provide this dynamic segmentation and policy enforcement. It's going to depend on what type of infrastructure you have. But again, Clearpass is that key, that hub of making sure that that we can talk to those different types of network infrastructure and have different enforcement policies sitting out there. And then finally, step 4 is really how do I make the security infrastructure integrated into the network? Ideally, I'd like the network infrastructure to be both a sensor for security and also be an enforcement point to help security do its job. And if we can share information back and forth through APIs, that becomes possible. So one example, perimeter firewall sees IP addresses coming through, but it doesn't necessarily know what those IP addresses are at any given time. We've got mobility, we've got DHCP, it could be changing all the time. Clearpass knows who the user is because it authenticated the user. And so it can communicate that information up to an edge firewall and say, this is this user and this group membership, and here's all the attributes we know about this particular IP address right now. That allows the edge firewall to make an access control decision much more intelligently than if all it has is IP address. Likewise, if something in the security infrastructure detects attacks taking place or something that's bad, we'd like to take action against that particular client device. We'd like to either get them off the network, slow them down, change their traffic forwarding path, whatever action you want to take. Through APIs, we can communicate that information back down into Clearpass, and it can then take that action in the network infrastructure. So Clearpass, again, acts as that hub to kind of glue these things together. So that's really, linking together our security infrastructure, our network infrastructure, and we're getting the best of both worlds out of that. So to wrap up here, this is my proposal. When we talk about zero trust, we may actually have kind of two flavors of zero trust, broadly speaking, and they're not. It's a false dichotomy to say that we do one and not the other. We actually need to do both. Zero trust applications, this is more of the Forrester concept of zero trust networking, of saying, let's move everything into a application layer framework where we've got authentication, encryption, access control, and the authentication and encryption happens between the client and all the way to the service endpoint. So it's sort of end-to-end encryption right between those resources that need access to the data. That's great when we can do it, and we absolutely should do that. We should absolutely shut down legacy services that don't support those sorts of things. So use this wherever you can, absolutely. But we've got a lot of other stuff out there that doesn't fit into that framework, and I don't know that that ever goes away 100%. And that's where I think Aruba fits in on the right side here, which is zero trust networks. Getting back to what I talked about before, don't have anonymous connections into the network. Make sure the AAA system sees every connection out there. That gives you the ability to apply controls at network ingress based on the identity of that user or that device or its role. Linking into the security infrastructure for real-time adaptation, and basically use this wherever you have to. Use this, if you've got IoT devices, if you've got legacy applications, if you can't do the thing on the left, if you can't do zero trust applications, this is what you're left with from a network standpoint. So, so definitely do that. So that's what I had for you today. I hope that was helpful. I hope you don't think that we're being too abusive with the term zero trust by linking it together here, but I think we need to be talking about more of a holistic story when it comes to this idea of zero trust architecture. We need to include the network layer as well as the application layer in order to get the best results. I know at the end of every session, we want to remind you the Airheads community is out there. Definitely, if you haven't joined that, you should. There's over 100,000 people that are a part of that. If you have questions about this session, be sure to post them up on the Airheads community site or use the feedback tool to do that, and tag me in, and I'm happy to answer those sorts of questions, and you'll get a lot of other Aruba experts on there as well. So with that, I hope you enjoy the rest of the conference. Thank you very much for tuning in.